Then you know this one, this angle, this guy is equal to 60 degrees, right? The reference angle of the theta is equal to 60 degrees. So theta prime is equal to 60 degrees. Then you have the cosine of negative 240 degrees equal to cosine 60 degrees up to a sine. Now tell me, what is the sine of the cosine negative 240 degrees? Positive or negative? Positive, negative? Negative, right? Because in the quadrant 2, the x is less than 0, is to the left of the y-axis, right? So you have the negative x coordinate. And cosine is defined as the x coordinate of the point of intersection. So in this case, you just prefix a negative sign to this cosine of the 60 degrees. What is the cosine of the 60 degrees? 1/2, right? So this is equal to negative 1/2. And we can also find sine of negative 240 degrees. So this guy is equal to sine of this reference angle up to a sine. What is sine of the negative 240 degrees? Positive or negative? Positive, right? In the quadrant 2, y is bigger than 0. So this guy is positive. And we know this is equal to root of 3 over 2. So finally, you get the root of 3 over 2. Now, let's look at the fourth and also the most important identity in trigonometry. It's called the fundamental identity. And I told you I write the square of sine alpha in such a way. This is same as the square of sine alpha. And similarly, you have the square of cosine alpha. So right now, let alpha be an angle in the standard position. So we know cosine alpha is equal to the x coordinate of the point of intersection, and sine alpha is equal to y coordinate of the point of intersection. And x and y are the coordinates of the one point on the unit circle, so it satisfies the equation of unit circle. So that is the x squared plus y squared equal to 1. So now you replace x by cosine alpha, y by sine alpha, then you get cosine square alpha plus sine square alpha equal to 1. And generally we write this sine square alpha first and cosine square alpha second. And this is a simple but very important and fundamental identity in this class. You need to memorize it. And even after many years, anything else you can forget, but you cannot forget this identity. If you forget this identity, that means you know nothing about trigonometry. Okay? Now let me show you one example. Let's look at the problem 90. Find sine of alpha, given that cosine of alpha equal to negative 4 over 5 and alpha is in quadrant 3. So it's on page 444. probability, we know cosine alpha is equal to negative 4 over 5, and alpha is in quadrant 3. Let me use the symbol, looks like E. For belonging to, this symbol means alpha is one of the member of the set. Okay, belongs to this set. So that means alpha is in quadrant 3. So now we need to find sine of alpha. And first, we begin with the fundamental identity. We have the sine square alpha plus cosine square alpha equal to 1. And then we move this cosine square alpha to the right side. We get sine square alpha equal to 1 minus cosine square alpha. Then we take the square root of both sides. So we have the sine alpha equal to the square root of 1 minus cosine square alpha up to sine. So right now we need to determine this sine. Alpha is in the quadrant 3. What is the sign of the sine alpha? Positive or negative? Quadrant 3? Negative, right? You see here, it's below the x-axis. In the quadrant 3, y is less than 0. So this guy is negative. So right now, we use the position of this angle to determine the sign of this sine alpha when we solve this equation for sine alpha. Now you can plug in the values. Okay, you can plug in the value for cosine alpha into this expression. You have the negative square root of 1 minus the square of negative 4 over 5. And this is equal to 16 over 25. And 25 minus 16 over 25. And you get the 9 over 25. Right? Take the square root. Finally, get the negative 3 over 5. Let's look at the problem 92. Find cosine alpha. Given that sine alpha is equal to negative 12 over 13 and alpha is in the quadrant 4. So 92. And we know sine alpha is equal to negative 12 over 13. And alpha is in quadrant 4. So first, let's determine the sign of cosine alpha. Positive or negative? Think again. So this is quadrant 4, right? And in the quadrant 4, x is positive, right? So cosine alpha is equal to the x coordinate of the point of intersection. So this cosine alpha is positive. And then from the fundamental identity, you have the cosine alpha equal to 1 minus sine square alpha, right? Cosine square alpha equal to 1 minus sine square alpha. Then you take the square root of both sides. Okay, considering the sign of this cosine alpha, you get the positive square root of 1 minus the sine square alpha. Now plug in the value for the sine alpha, you have the 1 minus the square root of 12 over 13, and this is equal to 1 minus 144 over the 169. 169 minus 144 over 169, and this is equal to 25 over 169. So finally you get a 5 over 13 and done.